Hi, my name is Brian Chan from Bachelor of Software Engineering, and in this video I'll be showing you my FYP project called Rover, an IoT lost item finding device. This project is about helping users in finding lost items at home. All the information about this project will be presented through a poster after the demo. So let's first dive right into the product, and I'll show you how the product actually works. Right now I'll show you how the Rover robot operates. So right here I have the mobile app, and as you can see here we have a roaming button, the alert button, and the bottom two buttons are to enter the family tree, not family tree, sorry, family list, and the other one will be, sorry, wait a moment, and the other one will be the lost items list, where you can actually identify the lost items found. So when you click on check, then you can see what the item is. This is a picture of what the Rover robot has actually taken. So now I'll show you how it actually detects an item. So I'll click on the roaming button right here. So the Rover robot is actually fetching a state data from the database every 5 seconds in a thread. So when I click on this roam button, then it will actually trigger a change in the state in the database, and then it will be fetched by this Rover robot, and then it will be able to know that it should start roaming. So it works vice versa. When I actually click it on the roam button again and then stop it from roaming, and then in the background of the Rover robot, it will actually fetch and trigger the stop button whenever it detects that there is a change in the state to make it stop. So I'll show you. I press on roam, and then it shows that it's roaming. So you need out. Now you see it's roaming. So it will roam until the machine learning model actually detects an item through the camera feed. So if I would like to make it stop, so it will wait a while, and then when it fetches a state, and then it will stop roaming. So what if I want to enable the buzzer? It should work now. Now it knows that it should start ringing, so the buzzer will activate. And now I would like to off the ring. So now the mobile app shows it's not ringing, and then after a while the Rover will actually stop the buzzer from ringing. It should work. So this is how the main part of how the mobile app actually will be able to control the Rover robot. So now let's just say that I put an item in front right here, and then I actually start roaming. I'll show you how the Rover robot actually takes a picture of the item and then be saved into the database to be displayed right here in the mobile app. So let me open the list right here. So there should be an existing 3 items that was pre-saved before this demo right here. And the Rover robot is actually taking a picture of the remote control right in front of it, and then saving it into the database. So as you can see right here, it actually detects a remote control and saved into the database to be displayed right here. So as you can see, there's a remote control. So previously there was only 3 cards, right? So now it has it actually took 2 pictures of the remote control. So this is how it mainly works, the Rover robot operation. So whenever it detects an item, it takes a picture of the remote control when it's stopped, as you can see right here, and then saved into database and then be displayed right here. So when the user actually wants to locate the item, so because when it's stopped and take a picture, then it will stop roaming as well. So when the user actually turns on the alert button, so then it will actually wait for it to actually activate the buzzer, and then the user will be able to follow the sound and then be able to locate the rover robot. So that's how it works. That's all from here. I have shown you how the actual product works, so now I'll be showing you how the machine learning model works through the Pi camera of the Rover robot. The reason why I'm showing you the machine learning model through this PC is because there is no way for me to visualize to you on how the machine learning model is running through the camera. So instead, I'll be showing you the model through the PC webcam. So I'll be putting a card right in front of the webcam, and as you can see, it recognizes it as a card and has a confidence level of 99%. So what happens when the machine learning model actually recognizes the item is, once the machine learning model gets a confidence level of above 95%, then it will take a picture of this item. For example, like this is a card, so it takes a picture of this item and be saved in your database. So the reason why I have set it to have a confidence level of above 95% is because this is to prevent the machine learning model from making any mistakes of saving unknown items into the system. So right here I have a remote control, and the model is also trained to detect remote controls. So what happens if an item recognized is not above 95% confidence level? Then the rover will actually continue roaming and not stop. So it will go around the house until it recognizes an item that is above 95%. And that's how the machine learning actually runs in the Raspberry Pi. Let's summarize this demo video using my FYP poster. So the problem statement of this project is the inability of users to retrieve lost items at home may be due to a lot of factors like furniture, lighting, and etc. Second one, some of the approaches are having short item detection range, requires too many hardware components to be utilized, but in this case we only need the Rover robot. And lastly, does not accurately locate the location of the item. This project addressed this problem by using a buzzer where users are able to activate the buzzer and locate the item. Moving on, this project aims to build an obstacle avoiding rover robot, to develop a mobile application that alert users, but also using the mobile application to control the rover robot. Lastly, to use object classification technology to recognize items. This is shown you in the machine learning model earlier in the demo. So the methodology used in this project is rapid application development. The results of this project is as shown earlier. We have the rover robot. We have the mobile applications. This is the dashboard page. This is the items page where we are able to use these pages to control the rover robot and also to identify items. And lastly, the machine learning item recognition, where we are able to use the model to recognize items. So the tools and software used in this project are the body of the rover robot, the Raspberry Pi components used, and the bottom ones are the software used in this project. We have Python, PHP for the backend, TensorFlow for the machine learning, Raspberry Pi are these components, and React Native, the mobile application framework that is used. The future implementations of these projects are implementing a security cam using the camera installed on the Rover robot. So by implementing a security system, our rover is able to help users in monitoring their homes when they are not there. Second one, providing a lost item recognition suggestion form. So this helps the system to be able to improve its machine learning model to help users to detect more items. And lastly, the mobile application to be available for iOS platform. So this is all from me. I would like to thank my supervisor, Mr. Yap Chi In. And that's all from me. Thank you.